Okay, let's say we are looking at a Rosetta gauge. So what this would be is three strain gauges arranged. You need three of them arranged on a surface, and that surface might be experiencing some strain in the X direction, Y direction, and maybe some shear strain as well. Okay. So because there's three unknowns, that's why we need three Rosetta gauges to find those particular values. And again, we can see that we will probably want to distribute them off into three different directions, so we can pick up the X coordinate, the Y coordinate, and any sort of rotating strain type behavior. This would be a classic arrangement where we can see that we've got them roughly, the angles between them are roughly equal angles apart, degrees apart. So you've got a 90 between A and B, and then 135 degrees between A and C and B and C. And that's obviously a nice thing to do because they're, nicely distributed. But the reason why we choose the 45 degrees, Rosetta gauges normally arranged such that they're either a 45 degrees or a 60 or a 30-degree angle, something along those lines from, let's say, the X coordinate direction. Because when you look at your formula sheet, you can see that you've got these causes and these sines, and so when we put 30 degrees, 45 degrees, or 60 degrees, we're going to get nice rational, irrational numbers coming out of them. So what we would want to do is we'd probably want to find the maximum strain, minimum strain, and also the shear strain. Now the shear strain isn't this term like it was with the shear stress. It's referring to the range that you can have in this orthogonal direction. So it's referring to twice that number. Another way to think about it would be the maximum strain take away the minimum strain. Obviously that will give you the same thing, twice that number. So that's what we want to do. So to use this equation, obviously we need to find epsilon x, epsilon y, and the shear strain gamma xy. So what I'm going to do to solve this is I'm going to use this equation 3 times and then work with algebra. So the top equation is just saying if I've got my epsilon pointing in an arbitrary direction, so this could be my arbitrary direction, could be going off down here, could be going off down here, or it could be going off down here. I can then find that made up of the strain going in the X direction, the strain going off in the Y direction, plus the shear strain I want my calculator. And okay, so let's work with this one first. So we are always going to try and orientate them such that we're going to get this arbitrary axis where we're pointing so that it rotates back to the x-axis here. That's our game plan. So then you say to yourself, how am I rotating? So I'm rotating in an anti-clockwise sense. These angles work on anti-clockwise. So that means it's going to be a positive number there. So the first one that goes in will be whatever the strain is measured at C, and I get a reading of 320 microstrain in C direction, and then whatever strain it is measuring in B, and I had a minus 230 microstrain, and whatever strain it is in A direction, so that's 110 microstrain. So actually we should do the A first, shouldn't we? So let's do the A, do them in order. So A, notice, has to go clockwise. So if you're going clockwise, you're going in a negative sense. So you've got 1, 1, 0. So that's the strain in the A direction. We don't know what the strain is along the X direction. And we're going to rotate our strain in that A direction so that it's pointing in the X direction. So we've going to gone minus 45 degrees. Let's do the same for the next one. I don't know what that strain is. And that's going to be there. So we notice, in actual fact, where we're at either side, we'd end up with the same because we're squaring these numbers, but not for this last bit. I don't know what the shear strain is. And what you want to do is you want to work out that value and tidy it up before you move on. So cos minus 45, let's square it, so that's a half. Sine 45 is going to give me the same, minus 45, half. And this is always good to use to find out whether it's a minus or a positive. So cos, cos minus 45 times sine minus 45. So it's minus. So let's tidy that up a little bit further. So we have 2, 2, 10. Right, so that's my first one. Let's do B now. So B is pointing off in this direction. How do I have to rotate this so it's pointing back to X? I have to rotate it a total of 135 degrees. It has a value of minus 230. Okie dokie. So what we're finding, because that's 45 degrees from that, because we're going to get the same as above, only this one's going to become a positive. So minus 230 half that plus half that. Don't believe me. XY, is that the cos? Let's put that in. Let's just check. Cos minus 135 times sine minus 135. Cos is symmetrical, sine is odd, and we end up with plus. That's the great thing when you use these nice angles like that. You can see that we're going to end up with some nice easy algebra. And I should put a half there. Right, so I can work out what the strain is in the XY plane if I took that equation away from that equation. One way of doing it. Let's do the other equation first. So that's equation 1, equation 2, the other equation. So that's this one down here. So it's minus 320. Now it needs to go 90 degrees to point back to x. It's a positive this time because it's going in an anti-clockwise sense. Plus, don't know what you are, cos 90, going to be a 0, sine 90. Right, so that would be 0, that would be 0, so we get minus 320 equals, that would be 1. Oh, no. Right. Where can I go next? Next thing I could do is to find the shear strain. So add the equation 1 and 2 together. So that's going to be 210 to 120, sorry, to go 320. So therefore we're going to have minus 100. This plus this will be 2 of them. This plus this will be 2 of them as well. So that would be minus what am I doing? I'm substituting in. So 2 that. So I've already found out what that number is. So that's going to give me 2 epsilon x, because minus 100 minus when it goes on the other side, so it goes plus 640. So the 320 doubled. Now we want to divide that by 2. And I've gone wrong. What have I done wrong? Okay, yeah, that's correct. That's correct. That's correct. What the hell am I doing? So it's this equation here and this equation here. 220 take away 460. I need my afternoon nap. Minus 240. Minus 240 plus 640 is 400. So the stress in the x direction will be 200 microstrain. Okay, so we take the 400 divided by 2, gives me 200. And now for the last thing, which is to find the maximum strain, the minimum strain, and also the shear strain. The shear strain is double that number. So let's start there. So shear strain is should be 1, take away 2. Equivalent to max, take away min. So that is going to be equal to 2 right, you notice you've got 2 there, and you've got 2 2's there, so we can actually cancel all those out. Square root. So 200, take away, it's my x, take away my y, which is this one here, so that becomes plus 320 squared. Strain, so what's the strain? Did I work it out? I didn't. So I've got the x, got the y, I need to use equation 1. So that will be, stop you for a minute, 220, take away the x, 200, take away the y, which will be plus 320. So we're using this equation here. And we're going to get the strain in the xy plane is 340. So now I can do this. So let's start again. So x is 200. Take away 320 plus 340. And that gives me a shear strain of 62129 microstrain. Okay, and then the final thing would be to find, let's say, the maximum strain. Probably interested in the maximum and the minimum. And we use this equation here. Okay, so this will be half this value. So let's divide that by 2. And now let's add on that. So that is minus 320. Actually, that was the y value. The x value is what? 200 minus 320. And then divide it by 2. And that doesn't look right. Oh, that's fine. Yes, correct. So 251 microstrain is the maximum strain, and take it away, you can find the minimum strain. If you want to try that, you'll get min strain is minus 371 microstrain. So notice that it's minimum in the sense that it's the most negative, max it's the most positive. Bit of a mess, I'm afraid, but hopefully that helps you to examine what to do when you are faced with a Rosetta gauge.